The letter on the left is always some sort of future amount. Okay? So that's going to be what happens later. And it's not always an A. The letter that's being multiplied by all the excitement in the problem, that's your starting or your original amount. Okay, and the formulas, like I said, are going to change from problem to problem, but you're always multiplying the starting amount times a bunch of stuff, and you get, as a result, the later amount. So when you're going from formula to formula, try to remember that. In this particular example, we are starting with $500. We are ending up with $1,000 with 6% annual interest. The twice a year is already included into the formula, so we don't have to worry about that. That's what that 2 is under the R. They want to know in how many years will the investment be worth $1,000. Now, to do any story problem, you have to know what letter you're looking for. In this case, in how many years tells me that I'm looking for T. So all you have to do in all of these problems is take the formula and fill in numbers for everything except T. Here's what that looks like. Just like that. The future amount is $1,000. The original amount is $500. The rate is 6%, which written as a decimal is 0.06. And T we don't know. So I have written the formula with numbers in for everything except T. And now my job is to solve for T. Step 1 would be, there's several things you could do. I'm going to divide by 500. That's going to cancel on the right side. And the left side becomes 2. On the right side, I have 6 cents divided by 2, which makes 3 cents, plus $1 is 1.03. So after 2 steps, I have that equation, 2 equals 1.03 to the 2t power. Once you write the equation, kids, you're out of the story problem. You don't have to worry about the story problem anymore. You're just solving an equation like we've been doing for a week. The variable's in the exponent, so we have to take the log of both sides. Sometimes today you're going to have to take the natural log because there's going to be an e in the formula. In this case, it doesn't matter whether you take the log or the natural log. To be safe, though, if you want, you can take the natural log every problem and be fine. So that's what I'm going to do. Natural log of both sides. The reason for that is to take the 2t and be able to slide it down front. And I'm moving over to the left side. The 2t comes down front of the ln 1.03. So I have 2t ln 1.03 equals ln 2. Now, I'm going to get rid of everything except the t. I'm going to divide that left side by everything except t. So the 2 and the ln 1.03 are going to be divided over to the other side. And the calculation I need to make is that. ln of 2 divided by 2 ln 1.03. When you do that, you're going to be canceling this and this, leaving you with just t, which is what we're looking for. So you have to make the calculation ln 2 divided by 2 ln 1.03. If you do that correctly, you get approximately 11.7. The next 2 examples we're going to do require different formulas. Here they are. One is y equals a times e to the kt power. The other is y equals a times 1 plus r to the t. In number 3, it says find k. So that must mean that we're going to use the formula that has a k in it. And the bottom formula does not have a k, so we're going to use it for number 2. Formulas are basically the same as the formula in the first one. You have some sort of initial amount being multiplied by something to a power, and that's going to give you the future amount. So what I want you to do is I want you to look at number 2. I want you to take this formula that's in black, and I want you to try to solve the problem. Divide by 20. And add the 1 to the 0.85. Hopefully you didn't have to put 1 plus 0.85 in your calculator. Log of both sides. Bring down the t. Divide by ln of 1.85. So there's your calculation right there. ln of 100 divided by ln of 1.85 is what you should be doing. And that is approximately 7.486 or 7.49 or 7.5, whatever, hours to go from 20 to 2000. It says a radioactive substance has a half-life of 32 years. What does that mean? Does anybody know? It means that half of the substance is going to decay in 32 years. So if you have 10 pounds of it sitting on your desk, if you come back in 32 years, there's only going to be 5 pounds of it sitting there. It's decay. Okay? We want to know the constant K for the decay formula for that substance. What you'll notice in this problem is they didn't give you amounts because it doesn't matter. Whether you have a pound or an ounce or a kilogram or 60 tons of this substance, in 32 years, half of it's gone. So if you have a ton, 32 years later, you only have a half a ton. It doesn't matter how much you have, half of it goes away. So what you get to do is you get to make up the amount you have. And the easiest way to do that is to say you had 2, and now you have 1. That's the easiest way to do it. Make up your amounts so it's easiest on you. Don't say you had 17.2 and now you have 8.6. This is going to make it more complicated. Right? Say you had 2 and now you have 1. And the time is 32 years. This constant is basically a fancy way of saying rate. Okay? So I'm going to divide by 2. I'm trying to get the k by itself. And if I divide by 2, I get 1/2 equals e to the 32k. And no matter what amount you chose, like say you chose, I had 6 pounds of the substance, now I have 3. Well, the first thing you would have done is divide by 6 and had 3 6, and it would have reduced to 1/2 anyway. So we're just eliminating that reducing by picking 2 and 1. We have to get the k down, so we're going to take the ln of both sides. And we learned last week that ln of e, the natural log of e, is 1. So that cancels or goes away. To get the k by itself, then all we have to do is divide by 32. And so my calculation is the natural log of 32 divided by 1/2, or no, the natural log of 1/2 divided by 32. Natural log of 1/2 divided by 32. This substance has a constant, should be negative, whatever we're getting, because it's decaying. Whenever you're decaying, your constant or your rate is negative. Whenever you're growing, your rate or your constant should be positive. So this one should be negative, and I get negative 0.0217. Try the one on the top with the brown y equals a times 1 plus r to the t formula. Setup. 100,000 is your future amount. 250,000 is your starting amount. Your rate, since it's going down, is negative 0.12. Oh. So when you start simplifying, what you should end up with is not 1.12 to the t, but really 0.88 to the t. Natural log of both sides. The calculation I'm going to make on my calculator is the natural log of 2/5, or 0.4, divided by the natural log of 0.88, which is roughly 7.168 years for your combine to go from 250,000 to 100,000.